using a physical barrier. Right? It is a physical barrier. Physical barrier is used to as a coating on the surface of metal. This is a physical barrier. So you can as use paint, or you can use oil, grease, or electroplating. Right? Now barrier is used here for what? To avoid the contact of what? Oxygen and also water, right? Oxygen and water, right? But there are some issues here. What are the problems of the method? There are some problems in this method, right? It can get coating get washed away or scratch. Coating may get washed away or scratched. If the coating is getting washed away or scratched, what will happen? Uh, even with the coating, even with the paint coating, from inside, the metal may continue to corrode. Right? Then, hence, metal may continue to corrode even where even where no coating is there. Even where no coating is no coating is even where a coating is not scratched. Even where coating is not scratched. Even where coating is not scratched, it may get corroded. Right? Okay. So that is the barrier method. Another one is called sacrificial protection. Sacrificial protection. Sacrificial protection. Sacrificial protection. Now, in the sacrificial potential, what they do is, for an example, if this is the metal you want to protect, right? Here, what they do is they are connecting it to a through a wire, metal wire, to a more reactive metal, more reactive metal. So now more reactive means this metal must be at the top of the reactivity series compared to the metal that we are going to protect. Right? This is the metal intended to be protected. Metal intended to be protected. Now remember, now if it is an electrochemical cell, right? Now this more reactive material is actually acting as a anode, acts as an anode. It is acting as an anode. If this is the cathode, then this is the acting cathode. So why it is called an anode? It is getting oxidized. Anode is always gets oxidized. It is getting oxidized. Oxidized means what? This anode is getting corroded, not the other metal. Right? The most reactive one is getting corroded. So it is being sacrificed. It is getting corroded. So that is why it is called a sacrificial protection. Sacrificial protection. Right? So this one is not getting oxidized. Even though it is being exposed to water and oxygen, all the electrons are taken from here. All the electrons are taken from here. Right? By water and oxygen. So for this metal, nothing is happening even though it is exposed. Right? Understood? Hello? Metal intended to be protected. Right? Okay. So for example, you can tell uh, iron is protected by iron is protected by more reactive zinc. Reactive zinc. Okay. Iron is protected by more reactive zinc. So the example is this is used in ships. An example in ships. Ships are found in where? Sea. Now in ships, always the if this is the hull of the ship, if this is the hull of the ship, cross section, right? The cross section of the hull of the ship is made out of iron or steel. Hull of ship made out of iron. Now you know it is always been exposed to what? Salt water. Here we have salt, sea water. Now, if you even try to paint it, still it is getting touched and getting damaged, and still it is being corroded. Therefore, what they do is they are placing zinc blocks outside. They are attaching zinc blocks. Zinc blocks as anodes. Blocks as anodes. Now, since there are these, they have these zinc blocks. It is being protected. Okay, understood? Hello. And there's the best method is if you can both use the barrier method and sacrificial anode. So therefore, the best method, but it is expensive, the hybrid method. It's called galvanizing. So galvanizing is actually a combination of both barrier and sacrificial anode and sacrificial anode. It's called galvanizing. In this case, a paint coat of zinc is applied, right? A paint coat of zinc applied on the metal you want to protect. You intend to protect, right? But it is expensive, right? Now, why it is at the advantage? Even it is scratched, still the protection is there. Even when scratched, zinc layer sacrifice itself, sacrifice itself, protecting the metal inside. Right? Even when it is scratched, still it is the inner metal is not getting corroded. Why? Still the layer is getting corroded. Right? But it is expensive. Okay. Now here I need to tell you something important. Right? What is important is corrosion means Oxidation of any metal. Oxidation, degradation of any metal, right? Rusting means oxidation or degradation of iron. That is corrosion. Rusting means rusting means a special term used for the corrosion of iron. Term used for the corrosion of iron. Is it clear? So with that we are done there. Now we can go with the oxidation and reduction. Actually, you are aware of it, right? But we haven't discussed about it separately. So let's talk about oxidation and reduction. And reduction. Right. Okay. Uh, Now oxygen means what? Uh, Give away electrons. Oxidation means give away electrons. Let's look at an example. Uh, Zinc, copper oxide, zinc oxide plus copper, which is being oxidized. Yeah. Which metal has been oxidized in this reaction? Which has been oxidized? Huh? Zinc. Got oxidized, right? Got oxidized. Why it is oxidized? Because it's the most reactive element. It is oxidized because it's the most reactive element. Since it's the most reactive element, it is getting oxidized. Reduction means gaining electrons. Gaining electrons. Here the copper has copper got reduced. This is the less reactive compared to zinc. That one is more reactive, this one is less reactive. Okay. All right. I will give you a question and you decide which one is in this one also. Which one is getting oxidized, which one is getting reduced, and you tell me how did you figure it out based on the charges. Based on the charges explained, how did you identify which is oxidized, which is reduced? This is the reaction. Vanadium 4 plus Fe2 plus. Check. We why you are telling it? Very good. Now the charge increased. Charge increased. Charge is increased. That is also called in oxidation. Charges are increased. In oxidation, it happens. Now between this and this, yeah, charges are lowered. Charge lowered. Charge lowered. It happens in reduction. That is why we call reduction, right? The reduction is the charge. Oxidation increase in the charge. Okay. Let's move on to the next one. Uh, we are discussing a practical. So practical investigate the metal reacting with acid. Metal reacting with acids. Investigate metal reacting with acids. Investigate metal reacting with acids. Okay. Okay, now it's a practical. Right, now it's a very basic experiment. We have three test tubes. Inside this test tube, we have an acid, right? Acids, right? Test tubes filled with an acid. Test tubes filled with an acid. With an acid. And we placed iron, metal strips, magnesium, iron, and here zinc metal strips. Magnesium, iron, and zinc metal strips of similar weight are placed. Magnesium, iron, zinc metal strips with similar weight, same weight are placed inside. Okay, all right. Then, so what we do is now we can use a splint, wood splint, like this, and we can hold it at the top of the test tubes and observe wood splint at the top of the test tubes and see. Now, what is the gas that we are expecting it to? What is the gas that we expect to see being released here? Yeah. What is the gas? Hydrogen with an acid like HCl. What do you get? Hydrogen gas, right? We expect to have hydrogen gas. So if there's a hydrogen gas, what do you expect to observe here? What else? With the spin, snake pops out, right? Yeah. Right. So let's write the observation table also here. Okay. Right. Here the metal. Dilute HCl. Dilute sulfuric. And here we have magnesium, iron, zinc. Now these are the observations. Dissolves very quickly, gets hot, gas given off. Pop with spin. Right? And also colorless solution. Rapid bubbling, pops loud, metal dissolves. With iron, much slowly, right? Very slow bubbling. Slow, small bubbles here. Slow reaction, small bubbles here. Zinc, bubbles given off. Metal slowly dissolves. Metal dissolves, colorless solution, forming a colorless solution. Gas given off quickly, right? Gas. Okay. Did you write it down? Did you write it down? Oh, right. Conclusion, right? Now the reactivities are in the order of magnesium, zinc, and iron. So you can decide this on by looking at this qualitative results. Magnesium faster, then the zinc, in the at last iron. Right. So with these observations, we can conclude on that. Right. Uh, and the other one is all three metals reacted with both the acids. Right. All three metals reacted, but at different rates. Right. All three metals reacted with the two acids. With the two acids, they started to react. And the other thing is we have identified the gas released. Hydrogen gas was released in all six occasions. Hydrogen gas was being released. Being released. Okay. Okay. With this, we are done with this section. We are still in organic chemistry. Now we are moving on to extractions, extraction and uses of metals. New subtopic, right? Still under inorganic. extraction and uses of metals, right? So now we are actually done with the reactivity series. Now we are at extraction and uses of metals. Under that we have sources of metals, extract extracting metals, using metals, and alloys. Alloys means mixed metals. These are the topics that will be covered under extraction and uses of metals. So I'm going to stop the class from here, and the next day start. Let's continue from here, right from sources of extraction of metals. Right. I'll end the class now. Take care. Bye bye. See you.